And without further ado, I'd like to introduce you to Anre Swart, who is the leader of the business development team at BlueNova. Anre has been working for many years in the power industry with Eskom, among others, but also with Scatec for the 40 megawatt project in Mozambique. And in general, she's just passionate about electrifying Africa, and she's now focusing on microgrid projects. That's the name many people use in South Africa to refer to CNI projects, not to be confused with mini grids. And so, Anre, very, very happy to welcome you today. You can unmute yourself, and I'm going to hand over to you so that you can start your presentation. Let me just give you the controls. There we go. And we are all ears.
Thank you very much. And thanks for that introduction as well. Just want to set up, ensuring you can see my screen.
Yes, we can see your screen, and maybe I can ask you to speak a little closer to your microphone or to speak louder.
All right, is that better?
Much better, thank you.
Okay, all right, great stuff. Thank you very much, everyone. And I'm looking forward to this session. Hopefully there's something that you can learn. And please feel free to ask questions right at the end, or make a note also in the questionnaire side, so that we can try and address some of the issues. So I think what's important, purely just, and that's why I made it Energy Solutions to Serve Africa. Coming from South Africa, we acknowledge exactly what's happening in Africa as well, where we currently are going through a whole load shedding exercise, and I trust that you understand what that is that we are scheduled at the moment at certain times to be without electricity. And obviously that's an inconvenience caused throughout, whether it's in your household, whether it's in a business, factory, etc. It makes life a little bit more complex. You have to plan a little bit better, or you need to start spending money in ensuring that you do have electricity in those hours that you don't have electricity. Currently, we are sitting, well, today, fortunately, we don't have load shedding. It's only scheduled to start again at 4. So there's throughout South Africa communication as well, indications of which stage. It can be a 2-hour, 4-hour, or 6-hour outage that you're experiencing. And again, you have to adapt. And it's only those that can adapt to these circumstances that will definitely be successful moving forward in all the industries that they are busy with. So just quickly, I think it's appropriate as well, just to give some background to BlueNova as well. BlueNova started in 2015, so we're a 7-year-old baby. We're starting to stand up for ourselves, and I'm feeling that we're starting to run around. So it's a good place to be. The economical booster is there at the moment. We are part of the JSE listed Reunert Group, which you would be familiar with. We are basically one of the largest consulting engineering firms in Africa, Southern Africa. And we are focusing on quality. We are focusing on standalone energy storage systems. And we've got a factory down in Cape Town, a warehouse up in Pretoria, together with a support team and in both of these areas. Then specifically today, I want to concentrate on our iESS, our Intelligent Energy Storage System. What is it exactly? Well, it's I'll go into the product just now as well, but it's a solution that you can place down as a centralized battery storage unit that can be charged, whether it's with solar, wind, generator, or connected to utility. And predominantly, we are focusing in discharging into residential. Here we're looking at gated communities or estates, there where you've got like 200 houses standing. Instead of supplying a solution during load shedding for each and every household, you actually just have to supply a centralized battery at the point of connection at the municipality or the utility. And with doing something like that, just changing where you do your installations, you can make massive cost savings. And it's purely because of the infrastructure that you are utilizing. On the commercial industrial side, obviously prior load shedding, we also, or just purely looking at backup solutions, we focused on the electricity tariffs, and there I will also focus a little bit later on, but there you're looking at arbitrage opportunities, peak shaving, load shifting. This is again reducing costs, electricity bills for businesses, and making enormous savings just by utilizing a battery together with PV for the business itself. Then in the agricultural, what we are currently experiencing, and I think throughout Africa, this is the one that everyone is can definitely feel, is the fact that we don't have electricity. There's not enough generation. So everyone needs to start generating for themselves. So in the agricultural specifically, there's a lot of economical boost again taking place. People want to grow, they want to move forward, they want to put up more pumps, etc. But the utility ESCOM can't provide them with these growth electricity that they require. So they have to make their own plans. And in this market specifically, a lot of PV is being installed together with batteries, because as much as PV is the answer or solar is the answer for a lot of people, it's just not catering for those early hours where you want to start pumping, for instance, into the farmlands, and in the evenings again. So it's those two gaps that we are trying to address as well. So looking at our ice specifically, it's a 6-meter or 12-meter container. It's divided into an AC room and a DC room. In the AC room, you are fitted with an inverter, obviously according to your size and specification. We start off with the smallest at the moment high voltage inverter available is 50 kilowatts and can go all the way up to 680. We can also do the 1 megawatt, but that will predominantly be in the 12-meter container. Then a fire suppression system to ensure that we are facilitating safety regulations as well and guidelines. Then on the AC side, on the DC side, sorry, you've got access control, because yes, it's a high voltage. And when I'm talking about high voltage, I'm talking high voltage DC. So anything above 100 volt DC, we regard as high voltage. So here predominantly, we're starting with batteries at the in the vicinity of 416 volt DC all the way up to 780. And then also having an HVAC, ensuring that optimal use of the battery is also ensured. So how do we physically do it? Just to give some, obviously cell selections is something that one has to look at, and obviously everyone around the table, people comparing batteries with each other or solutions with each other. This is something that you need to focus on. You have to go and look at the performance warranty, the depth of discharge, the capacity retention, this life cycle of the cells, temperature ratings, and then obviously C ratings as well. Only when you do that comparison, I would sit down and have a proper discussion if you want to compare batteries with batteries. Because if you have not done this exercise on your own, you would just think that I'm going to try and sell only my product. But if you go and deep delve into the cells and see exactly what warranties are stating, then you are making direct comparisons, which is good for the project execution. Together with this, we look at kilowatt hours delivered under the warranty. So we don't just look at the performance warranty. We totally also calculate what the kilowatt hours would be that we deliver. And then obviously standards, safety standards that we look for in the compliances are the UL 9540 and also UN 3480, which is for transportability. In BlueNova, we predominantly make use of the cattle cells and then also REP-Ts. They give us more than 6,000 cycles and have a warranty more than 10 years. With these cells, then we manufacture assemble into a module, 14.5 kilowatt hour modules, 52 volts. And from there, then we place it into our module racks. And in a 6-meter container, you can get 1.7 megawatt hours. Obviously, these strings are being built, all these modules put into series together, forming a string. And these strings all depend on the size or the rating of the inverters. Usually the voltage DC ratings nowadays for high voltage range something from 300 volt DC all the way to 900 volt DC. You can go higher, but then you start looking at other effects on your battery system as well and the electronics. The current inverters in the HV range that we are integrated with and that we are using in our solutions are the KWA, PCS, the Ario, which is also a South African brand. So as you can hear throughout and see, hopefully, we are really pressing for local content from BlueNova perspective. Being in South Africa and finding the challenges very uniquely also into South Africa and Africa, it's also nice having partners that understand the problems where we're coming from. The iESS inverter is also, I call it the South African brand of choice at the moment. A lot of people are making use of this inverter, and predominantly the iESS HPS series, which is a hybrid inverter. So with this, you don't need additional PV string inverters to be added. You can just bring your PV strings into your iESS inverter and then have a PV solution as well on the table. They also have the PCS series, and then only recently we've started joining partnership with AEG, and that's specifically also for solutions in seamless transitions. Again, from our perspective, we would use the inverter by choice of the customer to install into our product, or either again reassess what is the usage specifically going to be, and then determine what would be the most economical viable inverter to be used. In BlueNova, we really focus on our intelligent portion, and one of these components that we are using is our BMAC, the Battery Management and Control Unit. It's an interface that we can use so that we can remotely also see what is happening at the site or at the installation, record the performance history, and that's obviously for warranty purposes as well. It's a nice to have for a lot of people these days. Everyone wants a gadget. You want to see what's happening on your battery. Is it full? Is it empty? What needs to happen? It's very nice in the sense that you can do your firmware upgrades also over air, and it's got an AC power monitor. This is just giving you a quick overview of what the BlueNova BMAC will be providing. Here you can see over time from 8 to 2 in the morning, you've got your battery charge discharge. You can see what's happening to each of the batteries that is connected. You can deep delve even a little bit further. You can go into each and every cell voltage. And this is quite important for the performance of the battery. You want to know exactly what's going on in each of the modules. With this type of information, we are also able to fault finding or pre-incident occurring actually start saying, but something is not right. Just remember, cells, electronics, all of these things are not 100%. They can produce problems along the line. So it is good to be able to monitor what's happening inside the module, so that you can preemptively also do something about the situation, ensuring that you have the continuity of supply that you are looking for and the reliability. Then also, again, on our intelligence side, we've got our own energy management system that we call the RMAC, and with this device, we are able to ensure that we can do peak shaving, load shifting, voltage and frequency regulation, assist with microgrid controlling, and then obviously also just the normal backup. What we basically do is to say, in an integrated network, you've got a generator, you've got PV or solar, you've got your load, and you've got your battery. At any point in time, the RMAC would make the decision which of these sources would be the most suitable, costly, looking at it as well, cost effectively, be the right source to use during a certain period of time. Then just a quick reference to a few of our installations, this being our first installation in Africa, and this was in 2020 already. It's a game lodge just outside Windhoek in Namibia, where it was just too far from any distribution transmission lines. Together with the EPC and contractor, where there was nothing, we came up with a solution to put up a 280 kilowatt PV plant, together with a 251 megawatt hour battery, and then also obviously having a generator. Everyone has in this thing about generators. Generators are important because you can never predict and know exactly what's going to happen with the weather. If you are solely dependable on solar, you're going to have to think of how you're going to recharge your battery if you drain your battery as well during rainy seasons, etc. So in totality, this game lodge are able to provide for themselves, and sorry I didn't change there, but for less than R2, which is 10 cents US dollar cents, for the next 15 years per kilowatt hour. That is what they would be able to generate. That is what they are generating for themselves. And this just came to a more cost-effective exercise for them, instead of getting overhead lines being built to the game lodge from the transmission lines. Then also, currently what's happening, and specifically in CNI spaces, is when we look at malls in South Africa, obviously when it's load shedding, everyone is running away from home. They need to go to a restaurant, want to do shopping, just be where electricity is freely available. So obviously the malls are one of those places, shopping centers where people are gathering, and ensuring that they've got power during this time. We've installed in many places now already 500 kilowatt inverter together with 1.3 megawatt hours. This is our first installation in the Grove Mall in Gauteng, Pretoria, and there they're purely looking at backup. Then a very interesting case, and the largest installation that we've got currently in South Africa as well, is at the Paul Mall shopping center, and here it's a 1.5 megawatt with 4.5 megawatt hours. Now, they don't just use the battery as backup, they also have in their specific tariff structure in their electricity bill a component that's looking after the demand ratio, and with the battery we are able to shave the peaks, ensuring that they've got more of a flat line. They've got a rooftop installation of more than 3 megawatt peak, and obviously during a sunny day they totally almost go off grid, and this obviously has an impact on the municipality. So to ensure that they've got a more blended and a more ratio demand that is flat, they are making use of the battery just to bring in and conduct and say when exactly they have to use PV or battery or going back to the grid. Then also just quick on what's happening in Mozambique, also where there's villages without electricity. These little microgrids that's being created, 150 kilowatt inverters with 450 kilowatt hour battery solution, with approximately 100 kilowatt peak, between 60 and 100 kilowatt peak PV installations, totally off grid. And for the first time, these guys also in these villages have electricity. So this is obviously where my heart is and what makes me excited as well, ensuring that we can actually create these type of solutions and bringing people closer together through these type of connections. Then I just quickly want to touch base on the different business cases or the usages of these batteries, so that you can see what BlueNova really do, how we get involved. We are not an EPC, we are a manufacturer of these ice containers, but unless we understand exactly what the problem is or the challenges that's been faced, we can't provide you with the best of the best solution. So we do get involved. We try and understand as much as possible of the challenges that's been faced outside, and then we find a solution with all the partners, the EPCs involved, the client, etc. So these will quickly be the cases that I'm going to discuss: is the arbitrage, the backup, the peak shaving, the power factor correction, and the seamless transitions that you can do. For specifically in South Africa, and I know that there's a few of the other countries that also running on the time of use, where you've got during, let's say this is this summer season, you've got on a Sunday, you've got off peak throughout the day. On a Saturday, you've got from 12 o'clock to 6 o'clock off peak, and then you've got going into standard tariff times. And then in the mid or in the week times, you've got your peak tariff times from 7 to 10. So the red just indicates the peak times, and you can see it's those 7 to 10 and 6 to 8 in the evenings. That's the peak tariff times, and those are specifically times, if it's normal, that most people actually use their most consumption of electricity when they go home, starting making food, or in the mornings when all the businesses starting to get going. So during those times, you get these high peaks, and obviously you're being billed per kilowatt hour then as well. The opportunity lies then that you can do arbitrage. Now, I'll just take a quick tariff summary here. For the off-peak in the winter, you pay R1.50 per kilowatt hour, standard R2.49, and peak hours R7.11. This is in rand. Sorry, I didn't change this slide to dollars, but it's just giving you an indication. So what we are suggesting is to charge your battery during the off-peak, and which is predominantly in the evenings from 10 to 6. You charge it full at R1.50 and discharge the battery during the peak tariff times from 7 to 10 in the morning, for instance. With this, you can then obviously make a saving, and I'm just doing of R5.61 per kilowatt hour. Now, if you just start making a few calculations by yourself, you can make massive savings, but purely just discharging and charging your batteries at different times. During the day, you would then charge your battery from PV or excess solar, and then again discharge during the peak tariff times. Now, with these, we've done a couple of scenarios. Local cost of ownership, if you take, for instance, a 500 kilowatt inverter with a 1.5 megawatt hour battery storage, will be roughly 7 USD cents per kilowatt hour. That's over 6,000 cycles. Now, I mean, that's already quite impressive according to me, hopefully to you as well. Taking into account inflation of 5%, tariff increases at 8% per annum, over 10 years in a degradation and losses included, having an RTE of 88%. This is what we've calculated and that we can confirm already with some of our installations that's running on these type of principles. You're looking at savings of NPVs more than $550,000 per and also IRR of higher than 23%. Now, a lot of investors are looking at these numbers, and these are the numbers that's making it exciting for them to rather start investing into renewables. So from BlueNova perspective, we are able to assist you as well, putting these business cases together, having obviously all the information available. And this is what's making it lucrative in the C&I space at the moment. Only arbitrage makes sense when savings increase with excess PV during the day. So obviously the combination of having a PV installed, and this is what's happening in South Africa, a lot of rooftops has already been filled with a lot of PV. So it's making it's quite nice for and attractive to also now start installing the battery. Then shifting over back up without PV. So the example, once again, let's make use of the 500 1.5 megawatt hour storage, cost price minus 500,000. If you look at the cost of running diesel, because that is what a lot of people are doing, you are looking at around 50 cents per kilowatt hour at the moment. If you go into a stage 4 scenario where you've got 2 cycles per day, these are the load shedding activities, which are each about 2.5 hours per day. You can see that you're going to use, or the diesel savings that you're looking into if you start making use of a battery will be more than $250,000 per annum. The break even will be under 2 years already for certain circumstances. And obviously the advantage is the minimization of production losses and impact of power cuts. We get a lot of CNIs that just 5-minute interruptions are costing them a week to recover from. So they can't have these interruptions, even if they want to switch over to their diesel generators. Just the pure transition is making it quite a costly exercise for them. So obviously, again, if you can do the arbitrage, that definitely helps. The other positive with having a battery is purely just when load shedding stops, then the arbitrage continues and you've got an ongoing ROI. Yeah, I've got just a small, with our test PCS being made use of, how your installation would look like, ensuring that you've got the continuity of supply. Then just with PV, obviously the battery acts as a grid forming device during backup, and this is something that many people did not understand previously when they installed PV, because PV is so much cheaper to install. They did not understand that when the utility goes into load shedding, your PV also goes down because it does not have a grid forming device. Now, with having a battery installed and the inverters that we are using, they are forming then the grid or that frequency that's required. So nowadays, it's like you definitely have to install your battery with your PV to ensure that you are going to have no load shedding effects. Then obviously with the battery, the PV can be utilized, and it's also just leveraging the investment into the PV. And then with sufficient PV, you can charge your battery during the day. And this is giving the opportunity then for many businesses also to start thinking of totally going off the grid. Just peak shaving, a short application and how we would go into there. If you look at the original peak of 1 MVA, and you can reduce with a 500 kilowatt, 1.5 megawatt hour battery solution, reduce your peak to 500 kVA. So in South Africa, again, and I'm sure in many other cases around Africa as well, you've got demand charges. The demand is calculated per kVA. So if you use 100 kVA, or if that's your peak, that would be the cost that's going to be going onto your electricity bill. It's calculated, let's again, as an example, $16.50 per kVA. That's giving you more than $75,000 savings per annum. Now, again, for me, looking in rand value to it and looking at electricity bills, that is significant. It's sometimes up to 20 to 30% of the electricity bill that you can do savings purely by doing peak shaving. Now, when would you use it? Obviously, it's where there's a lot of machinery that starts up, and just settles down again. That would be predominantly where you would do the demand peak shaving portion, because you don't need to pay unnecessary for demand that's only sitting there for a couple of minutes every now and again. Rather shave it off, have a battery there, and reduce the electricity bills. Then just on power factor correction, I'm sure that most of you understand also that what you're trying to do is just to get your power factor to unity. And how you do it is through the inverter. It's actually not taking any, it's taking some of the battery capacity, but it's not taking a predominantly big percentage, because all you're actually doing is you're playing around with the current curve internal to the inverter and trying to bring it back to unity. Again, just if I make a quick example here, you're sitting with a power factor of 0.7. Your kVA rating is 1,000, kVR is 720, and your kilowatt is 700. If you, after applying a power factor correction through your inverter in your iSolution, bringing your power factor to 1, and then the kVA is dropping from 1,000 to 720, for instance, taking away your kVR completely and still having your power output at 700, you can make savings of more than $250,000 per annum. So this is quite something that a lot of people are starting to look into as well, ensuring that they've got a better power factor at the factories. And then just lastly, the biggest challenge currently faced, and this is our largest project that we are busy with currently in South Africa, as well as a 6 megawatt by 18 megawatt hour at midstream estate, so gated community, as indicated earlier this morning as well, where you want to do a solution at one central point. So at the point of connection, now in a estate of this size, they've got more than 6,000 houses. Obviously, there's different transformer points at different areas, a ring network running at 11 kV. So from our solution, that's a 400 volt AC output, we need to get to 11 kV as well, so that we can built into the existing reticulation network. And this is actually quite a challenging exercise at the moment, because everyone is looking for the seamless transition. Because what's happening is, yes, you are indicated when the power is going to be turned off, but not necessarily all inverters can just switch on to that portion. Yes, John. Sorry.
No, so sorry. I was I was just scratching my throat. But yes, we're going to need to wrap up so that we can also give the time for the other presenters today.
All right.
Oh, but this was the end of your presentation.
That was the last slide. It's just, I think, just wrapping up here with the right information available, we are in a position to find a solution for any situation that you can go into. On-grid scenarios, obviously, you can just use multiple of these ice containers. I'm gone. You can still
I will bring you back, no worries.
Okay. All the on-grid solutions, you can obviously go multiple of these containers just being placed in parallel. Off-grid scenarios is obviously a little bit more difficult, and that is where you need to know the different solutions on the table, technologies available. At the moment, with AEG is the only seamless transition inverter that you can use that we know of, and so therefore you can go up to 8 megawatts. So yeah, that in totality, hopefully there was something of interest that
well, we've been quite bombarded with questions. Can we have the slides? Can we have the slides? So yes, definitely we will share the slides. But I think the clear message from your presentation, first of all, thank you very much, because you've shared very precise case studies and numbers about specific cases. And that's very much appreciated, because everybody is always looking for this kind of indication, even though I think everybody on the call today understands that one situation is always different from another situation. And so that would be my one question to you. Like you said, you are a solution provider, but you're not an EPC company. So let's imagine I own a factory, and I'm definitely looking into this, but I'm looking for a storage solution and I'm looking for a solar solution. What is the best way to work with you, but also with these other few solar companies that I would be approaching? How is this connection there? What do you recommend? Very briefly.
Yeah, so at the moment, I mean, obviously, I think batteries are where solar was 10 years ago. Everyone is still learning. The learning curve is exponential as well. So my suggestion would be make contact with us at BlueNova, and then we'll guide you. Either you bring your solar installer to the table, or we can also bring a EPC to the table that we can join forces with. So just don't exclude us, obviously, in the conversation. But I think the main thing is really like, and just make contact with us and we'll find a solution together. If we can't help you and we can't provide you with a total solution, we'll definitely direct you into a direction where someone will be able to assist you. But as I said, I think the challenges are there, but we do have the capability to assist with most of these challenges. But yeah, EPCs, we are working hand to hand with these EPCs, with new installers, new partners. There's a few, and this I want to reiterate, there's a few EPCs that knows batteries. So the battery supplier is definitely going to be very involved in the solution finding and putting the whole design on the table.
Wonderful. Well, I think the message is very clear. Thank you very much, Anre. We will share your contact details with everybody who has signed up and is listening today, so they can be contacting you later on and further discuss their project. Thank you very much.